Now, let's introduce you a new concept of probability. This is called conditional probability. How are we going to read this notation? We begin with a vertical bar. We say, given that, okay? Given that B has occurred, given that B has occurred, the probability of A, okay? Let me try one more time. Given that B has occurred, what is the probability of A, okay? How we define the conditional probability of A, given that B has occurred? Well, if I put three short lines, that means what? Probability A given B is defined to be probability A and B over probability B. Okay, three short line here means what? Is defined by, okay? This new notation is defined by this, okay? Now, to understand the definition in a more intuitive way, again, we can assume the sample space is equiprobable, okay? We can assume the sample space is equiprobable. Now, probability A, given that B has occurred, is defined to be probability A and B over probability B. If we assume sample space is equiprobable, if we assume sample space is equiprobable, then probability A and B is number of outcome in A and B over number of outcome in S, and then divided by number of outcome in B divided by number of outcome in S. After the cancellation of the common factor, number of outcome in S, we have number of outcome in A and B over number of outcome in B, okay? And what does that mean? What does that mean? Let's give a little bit further discussion, okay? Now, PA is the unconditional probability of A. And how likely you're going to see A happen depends on what? The ratio. PA is equal to number of outcome in A divided by number of outcome in the sample space. This is unconditional probability. In an unconditional probability and event A, the chance that we're going to see event A happens depends on the ratio. If the number of outcome in A is very close to the number of outcome in the sample space, then probability A is big. A has a big chance to happen. On the other hand, if this ratio is small, very unlikely going to see A happens, okay? So the comparison base is how many outcomes are there in the sample space. However, this is not the case for what? For conditional probability. In conditional probability, the comparison base is no longer what? How many outcomes in the sample space. Instead, it becomes how many outcomes in B. And what is the meaning behind this? Let's see. Let's look at the picture. In conditional probability, probability A given B. If we assume sample space is equiprobable, it reduces to how many outcomes are there in A and B, and then divided by number of outcomes in what? In S. Now the comparison base is no longer the whole sample space. It's simply what? It's simply how many outcomes in B. Okay? And what does that mean? Well, in unconditional probability, what will happen for sure? The sample space will happen for sure. But in conditional probability, what will happen for sure? B will happen for sure. Why is that? Because I told you that, okay? Given that B has occurred, we know B happened for sure. So B replaced the role of the whole sample space. And that is to say, in conditional probability, I'm no longer interested in what? In the whole sample space, okay? I'm no longer interested in S. Instead, I only interested in what? In B. An outcome in A, but not in B. Sorry, I'm not interested. I only interested in those A that also what? In B. That's why I only interested in what? Those A inside B. Okay? So, given that B has occurred, what is the probability of A? Is a ratio of what? Number of outcomes in A and B. Is this shady area. Okay? Divided by number of outcomes in B. Divided by what? The whole B here. Okay? You want to copy? Go ahead.